7, two similar polygons. Two polygons are similar if their corresponding angles are congruent and corresponding sides are proportional. This proportion is called the scale factor, and we saw that yesterday with dilations. So if triangle ABC is similar to triangle DEF, we write that using that kind of squiggle symbol in between. And what this really means is similar to how we did congruency statements. We're kind of matching the letters. So A is the first letter, so that means angle A is going to be congruent to the first letter in the other triangle, so angle D. Angle B is going to be congruent to angle E, and angle C is going to be congruent to angle F. This also means that the sides are proportional. So the first two letters from the first triangle are going to be in proportion with the first two letters from the second triangle. And that same proportion, that same ratio is going to be for every set of sides. So the second two letters with the second two letters. The last and the first with the last and the first. So assuming that the quadrilaterals here are similar in this example, what we want to do is write a similarity statement and then identify what we know about the sides and the angles of the figure, similar to what we just wrote out. So here I see I have a quadrilateral ABCD, and we are going to say that that is similar to quadrilateral EFGH. So what that means is that angle A is going to be congruent to angle E. Angle B is going to be congruent to angle F. Angle C is going to be congruent to angle G. And lastly, angle D is congruent to angle H. We also know that their sides are going to be proportionate. So AB is going to be proportional to EF. So AB over EF. That ratio is going to be the same as BC to FG, which is going to be the same as CD to GH, which is going to be the same ratio as DA to HE. All right, and the next one, we're saying we want to determine is triangle dog similar to triangle cat. If so, we want to find that scale factor, and that scale factor is going to come from really doing that ratio. So we see we have congruent angles C and D, good, A and O, good, the middle letters, and T and G, the end letters, good. Okay, so our angles are all congruent, check. Are our sides proportional? So we want to compare those sides. So DO and CA should be compared to each other. So we have 12 and 18. We want to compare AT to OG. So we've got 14 for triangle dog and 21 for triangle cat. And then we have 8 and 12 for the last two sides. We just want to make sure, are these all the same fraction? Are these all the same proportion? Well, 12 over 18, that's going to simplify to 2/3. 14 over 21, that's going to simplify to, let's see, that's also 2/3. And 8 to 12, that's also 2/3. Since they are all equal to each other, then they are proportionate. So that means that our scale factor is going to be that 2/3. Okay. Let's take a look at the next one. So here the figures below are rectangles. Is meow similar to bark? Okay. So we want to compare. Now, if we know they are rectangles, we know that opposite sides are going to be congruent. So that's 9, the bottom's 9. If the right's 12, the left's 12. Same deal here. Okay, we also know that if it's a rectangle, all of our angles are 90 degrees, which means that our angles are certainly going to be congruent. We want to make sure our sides are proportional. So MW and BK, that's 12 over 10. ME over BA, that's 9 over 6. And the ratios are all going to be the same, 12 over 10 again, and 9 over 6. We just want to make sure, are those the same proportions? Well, 12 over 10 is going to simplify to 6 over 5. 9 over 6, those are divisible by 3. That's going to give us 3 over 2. Definitely not the same fraction. Even if we compare the decimals, that's 1.2 and 1.5. So these are not similar, and that's really because they are not proportionate. Okay. Using our similar polygons, we can find missing information here. So we're saying that they are similar. You're told that they are similar. We want to solve for x. Well, we're looking for x, which is side ST. ST is the last two letters, so we have NE here. Okay, so we're definitely going to compare those two sides together. All right, so we have x from the first triangle over 24. Now we just need to pick two other sides to compare. How about the bottom two, RT and LE, the outside letters? So that's 15 over 10. I just want to make sure everything's lined up. So x and 15 came from the same triangle. Perfect. 24 and 10 came from the same triangle. Perfect. X and 24 are the sides that go together, and 15 and 10 go together. All right, now we can just cross multiply. So x times 10, that's 10x. 24 times 15, that's going to, let's see, 24 times 15 is going to give us 360. And then we can just divide by 10. And we're going to get that x is equal to 36. All right, let's take a look at the next one. So Jack is similar to dine, and we want to find x. Same kind of concept here. So AC, we see are the middle two letters. That's going to go with IN. We see that CK, the last two letters, is going to go with NE. So we can set up this proportion. So we have 4 over 2x minus 1. And that's going to equal 5 over x plus 4. And now we can cross multiply. So 5 times 2x minus 1. And that's going to equal 4 times x plus 4. Oops. All right, and now it's algebra 1 from here. So that's 10x minus 5 is equal to 4x plus 4, or sorry, 4x plus 16. Subtract the 4x, add the 16, or sorry, add the 5 to the 16, and get 21. And then when we divide here, we're going to get x is 3.5. And that's all it said, just find x. All right, in number 3, it's asking a very similar kind of question here. We see that JLM and QST are similar. Now, notice the lettering and these triangles are not quite turned the same direction. We need to go by this statement. That's so important. All right, so JL, the first two letters, goes with QS, JL and QS. So we have 3y minus 2, and we have 5. Okay, another two sets of sides. We have LM, the last two letters, so that goes with ST. So we have 6x minus 3, and we have 3. These are from the first triangle. These are from the second triangle. Actually, that's not going to help us, though, is it? We only want to solve for one letter at a time. So why don't we, instead of using the blue side, why don't we see what's left? How about, let's use this. JM has 4. And JM, the outside letters, go with QT, which is 2. Then we can go back and solve for the X one later. All right, so again, cross multiply. So we have 2 times 3y minus 2 is equal to 5 times 4. So that's 6y minus 4 equals 20, or 6y equals 24. So y is going to equal 4. Awesome. Now let's go back and do the same thing, but for the x's. All right, so we already said we have 4 and 2, those yellow sides, but now we need to use the blue sides. So we have 6x minus 3 and 3, and just same deal, cross multiply. So 2 times 6x minus 3 is equal to 3 times 4. So 12x minus 6 equals 12. That's going to give us that 12x is equal to 18, or x is 1.5. All right, and last couple things, perimeter of similar polygons. So since the sides are going to be proportionate, that means that their perimeters, which is just the sum of the sides, is also proportionate. So here we have two rectangles. We want to compare their perimeters. So we know with rectangles that opposite sides are congruent. So my perimeter here is going to really just be 8 plus 12 plus 8 plus 12. So that means my perimeter is 40. Okay. In my other shape, we have 9 and 6. So that means my perimeter is 6 plus 9 plus 6 plus 9, which means I get 30. So we want to compare these perimeters. Well, we see we have 40 for one shape and we have 30 for the other, and that's a ratio of 4 to 3. Well, we could do the same thing if we compare the sides. Here we have 8 and 6, the shorter sides, which is also 4 to 3. 12 and 9, which is also 4 to 3. So that means that our perimeter is really going to have the same scale factor proportion going on. So if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding sides. Same scale factor. So we want to find the ratio of the perimeters of the figures below. We could solve for the perimeter of each of these, but that seems kind of silly when we could just compare their ratios. So find two sides that are going to match up. How about this angled side here? And we have 7 to 5. Here we go. All right, and then it says to find the perimeter of triangle DEF. So we want the perimeter of this one over here. AB is 5, DE is 3, and the perimeter of ABC is 18. Remember, we said they are proportionate. So AB and DE should be proportionate. That's 5 to 3. They should have the same scale factor. And we also know that our perimeters should be proportionate. So we have 18 and our missing part. So we can call that X, or P if you want to use P. All right, so 5 times X, 18 times 3. 18 times 3 is 54. And then when we go to divide by 5, we're going to get 10.8. All right, last but not least, a couple of statements here. We say that similar figures are also congruent. That is always, sometimes, or never true. That is sometimes true. It can be the case, but more often than not, only their angles are congruent. And lastly, congruent figures are also similar. That is always the case because that means they would just have a proportion of 1.